Hello and welcome to this product overview of GEM's comprehensive pile foundation analysis software developed by Geotechnical Engineering Modeling Software, GEMS. Geotechnical Engineering Modeling Software, GEMS, develops feature-rich, easy-to-use CAD software for foundation design and analysis. GEMS Foundation Analysis Suite employs finite element modeling techniques for design and analysis of shallow and deep foundations. The Foundation Analysis Suite includes applications for analyzing beam foundations and combined footings, a comprehensive application for modeling pile foundations for land, bridge, and waterfront structures, and a specialized application for analyzing offshore pile foundations. Please subscribe to this YouTube channel to stay abreast with our product offerings, demos, technical talks, and other informational videos. Piles are used to provide foundation support to wide-ranging structures such as buildings, bridges, wharves, jetties, and towers. The GEMS Comprehensive Pile Foundation Analysis software supports analysis of land, bridges, and waterfront piles. Loading on the pile can be in axial direction, both compressive or tensile, and in lateral direction, namely shear and moment. The key differentiator the software offers is a single platform consideration of different soil strata, pile sections, pile types, codes of practice, as well as other well-known procedures adopted in practice. The software includes modules for pile capacity estimation, axial load analysis, and lateral load analysis. The software includes both linear and nonlinear methods of analysis. Various common procedures for analysis used in practice are included in the package. Some of the salient features are: the application can analyze driven cast in situ and board files. Files of different cross-section and with enlarged base can be evaluated. Axial pile capacity estimation, load settlement analysis, lateral pile analysis of piles under combined lateral and axial loads. Various soil types, clay, sand, and rock, and soil conditions such as groundwater table and scour can be taken into account in the analysis. Simultaneous analysis up to 8 loading scenarios. Loading may consist of axial loads, and lateral moment. Static and cyclic loading of the pile can also be incorporated for lateral analysis. Application supports generation of PY, TZ, and QZ curves based on soil properties. Pictorial representation of pile and soil layers. Graphical representation of loading diagram for each load case for easy visualization of the loading. Sulfate of the pile may be included if required. Facility for prescribing pilehead properties such as lateral displacement, rotation, and rotational spring. One can model pile group effect by user-prescribed P multiplier, Y multiplier, and Z multiplier. One-click computation and analysis of all load cases and modules. Computation is available also on a per module basis. Export of results to Microsoft Word and Excel. Application supports Windows 7, 8, 10, and macOS platforms and is also available for use using a browser on the cloud. One can use SI units or commonly used American units such as kips and feet. Our founder and professor V.S. Chandrasekharan will share some detailed insights of the application capabilities.
We shall now briefly look into the technical highlights of the three modules: axial capacity estimation, axial pile deformation analysis, and lateral pile analysis. All the analysis take into account the soil profile, groundwater table, and local scour conditions at the site. An embedment requirement of 3D is incorporated for the development of full base resistance, and a minimum cushion of 3D is prescribed above weak layers to avoid punch through. The axial capacity is the sum of shaft friction and base capacity. In clay strata, the shaft friction is estimated by one of the following four methods. The unit shaft friction is usually expressed as alpha into Cu, where alpha is a multiplier coefficient. In the first method, alpha is related to the cohesion of the soil. The BIS method belongs to this category. In the API method, alpha is related to the Cu. The ratio of Cu and vertical effective stress PV dash. The higher the value of Cu by PV dash, the lower the value of alpha. The third and fourth methods take both Cu by PV dash and L by D ratio of the pile in the estimation of alpha. The unit base resistance in clay is estimated as Nc times Cu. Skempton's value of Nc equal to 9 is widely popular and is used. In strand strata, the shaft friction may be estimated by using the following methods. APA 2014 beta method, the unit shaft friction is estimated as beta into PV dash. In APA 2000 K delta method, it is estimated as K into tan delta into PV dash, in which K is the lateral net pressure coefficient and delta is the angle of interface friction between the pile and soil. K delta method, along with the limiting vertical effective stress, PV dash equal to gamma into ZC, where ZC is a critical depth, is also available. Meyerhoff's SPT method, based on average N value of the layer, is also available. Base resistance is estimated as PV dash into NQ, where NQ is bearing capacity factor. Values of NQ may be directly given by the user as in API method along with a limiting value. In the IS method, NQ is based on NQ phi curve along with a critical depth factor ZC to limit the vertical stress. Berzon's bearing capacity factor for NQ along with the value of ZC may also be used. Meyerhoff SPT method based on the N value in the founding layer is also available. In rock strata, the shaft friction is estimated as alpha into square root of unconfined compressive strength and base resistance equal to beta into unconfined compressive strength. The results are presented in the form of shaft capacity, base capacity, and total capacity curves along the pile. Axial pile deformation analysis. The pile is modeled as a structural member supported on the sides by the soil, represented by a series of vertical springs, and at the base by a vertical spring. The side springs enable load transfer along the shaft, and the base spring at the pile tip. For all the layers, the strength of these springs are obtained from the pile capacity analysis in the form of unit shaft friction and unit base resistance. The stiffness of these springs are represented by a set of nonlinear TZ curves for each layer and a QZ curve at the pile base. Two approaches are available in the software for developing TZ curves. Nonlinear TZ curves based on API recommendation, bilinear model comprising of an initial slope of TZ curve using an elastic modulus and a parameter zeta based on Randolph's work. In the base resistance is modeled by a QZ curve. Two methods are available for constructing QZ curve. A nonlinear QZ curve based on API recommendations, bilinear model using elastic modulus of the soil at the base, and Boussinesq equation for rigid base settlement. A finite element formulation of pile supported by TZ and QZ springs combined with an iterative approach is used to analyze the pile for a given load. The results are given in the form of a set of TZ curves for each layer and a QZ curve at the pile tip. For a given load, the results comprise of pile head displacement, load distribution along the pile length. By carrying out the analysis for different vertical loads, load settlement curve of the pile can also be obtained. Lateral pile analysis using POA curves. The pile is discretized into a number of bending elements. The lateral soil support is modeled by a series of lateral springs represented by POA curves along the pile length. The parameter P is the lateral soil resistance per unit length of the pile and Y is the lateral displacement. The software can be used for developing POA curves for all layers. The following methods are available for constructing the POA curves. In soft clay layer, API nonlinear model and a bilinear model based on horizontal subgrade reaction Ks equal to NH into Z. In stiff clay layer, API nonlinear model, Rees nonlinear model, and a bilinear model based on horizontal subgrade reaction KH are available. In sand layer, API nonlinear model and bilinear model based on horizontal subgrade reaction Ks equal to NH into Z are available. In weak rock, Rees nonlinear model is available. In strong rock, Turner's bilinear model and horizontal subgrade reaction based on KH are used. Pile head conditions. The following pile head conditions are available. No condition or free head, prescribed rotation, and prescribed rotational stiffness. Lateral load and moment could be applied at the pile head and in addition to a vertical load. The FE model incorporates the beam column effect. The results are presented in two parts. The first part consists of a set of PY curves for each layer under static loading conditions, a set of PY curves for each layer under cyclic loading conditions. For each loading case, second part results consist of lateral deflection and slope diagrams, shear force and bending moment diagrams, and soil pressure diagram.
The software is available for a 30-day trial download from our website for Windows and Macs. One can also try the online cloud version for 30 days from our website using a browser. There are no analysis restrictions on the trial version. After the trial period, one can subscribe and continue using it for a very competitive price. Do visit our website for additional details on this application. Download the trial version or sign up for the cloud version and try it out for yourself. The software is very intuitive and easy to use. You can also watch the quick start guides from this YouTube channel if you need help getting started. There are also some example problems available for download. The links are also summarized below this YouTube video. Again, like this video, share with others, subscribe to this channel to stay up to date. If you have any queries, please email us at support@gemsoftware.org. Thank you for watching.